All right, folks, it's back in action here. In this video, we are going to go through the last two proofs related to our sum and difference formulas. We're going to look at the proof for the sine sum of two angles formula and our tangent sum of two angles formula. So we're going to show that the sine, cosine, cosine, sine pattern holds true, where the A and the B follow the same pattern of A and B, and if this is a plus, this is a plus. Now, this entire proof is going to hinge on this idea right here, the fact that sine theta is equal to the cosine of 90. Remember, that's pi over 2, 90 minus theta. This, recall, is also at the top of your foldable here, where we reviewed the complementary cofunctions in the previous video and we covered in the last chapter. So that's where this proof is going to start. We're going to rewrite this part right here, and this is going to be the start of our idea. We're going to say sine theta, and recall that that's going to be equal to pi over 2 minus theta, okay? Now, what we want to do is we want to define that this theta, okay, we're going to do that right here. We're going to say that theta is going to be a plus b, because that's what we're trying to do. We want to show that not just sine theta, but we want to show that sine of a plus b. So we're going to say theta is a plus b. So if we substitute our theta is a plus b here, we need to substitute our theta of a plus b right here as well. So all we've done is taken our pi over 2 minus our theta and made it a pi over 2 minus an a plus b. Now, of course, that means that we could distribute this negative here. So we could distribute that negative and make it a minus a and a minus b. And if I do that, what I can do is I can regroup it. So when you look over here, what we're going to do is we're going to substitute this in, but we're going to regroup it. So we're going to have our pi over 2 minus an a, and then we're going to have minus a b, because that came from the fact that we distributed our negative to both of those angles. Now that we have this here, we've got this in terms of cosine, and this is where the proof from the previous video is helpful, because you have to understand that and believe that that proof is true, because we're going to apply that here now. We have already proven our cosine sum and difference formula, so we can go ahead and apply that now to this. We're going to expand using our cosine, cosine, sine, sine. So we're going to say cosine. And remember, that's going to be of our first angle, and our first angle is actually this entire expression right here. So we're going to say cosine of pi over 2 minus a. Cosine, cosine, so we're going to say cosine again, and this time it's going to be cosine of b. Remember, on the cosine formula, we're going to change this from a minus to a plus. And now we can do sine, and again, our first angle is pi over 2 minus a, and then sine again of angle B. Now that we have that cosine, cosine, sine, sine, notice that we're back to this complementary cofunction idea. The cosine of pi over 2 minus a, that's our 90 minus a, that's going to be the same as the sine of angle A, because our complementary cofunctions are going to say those are the same. Then, of course, we can just rewrite our cosine B here. Then we've got our plus. Again, sine of pi over 2 minus a, that's our complementary cofunction, so that's going to be the same as the cosine of a. And then I can just rewrite the sine B. So sure enough, there is our sine, cosine, cosine, sine, and now we understand how that turned into a plus. Okay, now the last formula or proof that we're going to do is going to be the tangent one. This is going to be an important idea because we're going to come back to the concept that we apply in this proof to some of our other identities later. So the theorem that we're trying to prove is that the tangent of a plus b is equal to the sum of the two tangent values in the numerator and 1 minus the product of the tangent values in the denominator. So we're going to start with this left-hand side because that's how our proofs are going to work. So we're going to start with this side over here. And we know that tangent is sine over cosine. So I can rewrite this as the sine of a plus b over the cosine of a plus b. Now what we're going to do is we're going to expand this. We're going to expand the numerator using our sum of two angles, using our sine formula, because we just proved that, so we know it's true. So we're going to say sine A cosine B. So sine, cosine, remember the sine is going to stay the same. And then we're going to do cosine A, sine B. So we've got our sine, cosine, cosine, sine. And then that's all going to be over. We're going to expand the denominator of cosine. And that's going to be cosine, cosine, sine, sine. This is another way that you can expand this and maybe make it a little easier for yourself. Fill in the pattern of the sines and cosines, fill in the pattern of the letters, and then fill in the appropriate sign, and that'll become a minus. Now, the trick to simplifying this to what we need it to be is to go back to where we're trying, look at where we're trying to go, and notice that we have this really nice 1 right there. So if we can figure out how we could create a 1 out of this crazy expression here, we'll get to our answer. So we're going to find that same position. I've got a 1 here, and I'm going to kind of draw my eyes to this portion right here. Okay. I know that if I divide something by itself, it's going to equal 1. So what I'm going to do is, I know if I divide this by itself, I'll get the 1. But if I divide this by cosine A, cosine B, I need to divide everything by that. So that's what I'm going to do. I'm going to take sine A, cosine B, and I'm going to divide that by cosine A, cosine B. Then I'm still going to have cosine A, sine B, but I need to divide that also by cosine A, cosine B. Then that whole thing is going to be over, I'm going to smooth this up here a bit for us. That's going to be over cosine A, cosine B, and that has to get divided by cosine A over cosine B, minus sine A over sine B, and that's going to get divided by cosine A over cosine B. Now all we have to do is start canceling and cleaning things up. We're going to go bit by bit. When I look at this part right here, I can see the cosines are going to cancel. And what's going to be left is, oh, I totally forgot to write that A. You guys probably already caught that. That's going to leave me with a sine A over a cosine A, and that's, of course, tangent A. On my next part, I can see that the cosine A's are going to cancel. And that's going to leave me with sine B over cosine B. So that's going to become plus tangent B. In the denominator, we know this is going to be 1 because that was the whole point of it. That was how we set it all up. Then we're going to have our minus. And in our last part here, sine over cosine is tangent A. And sine over cosine again is tangent, but this time it's B. And sure enough, that's exactly where we wanted to go. So that idea of being able to look for something that to create a particular term is something that you do need to be familiar with because it's going to pop up in some of our later identities.